Today is 12.3 using proportional relationships. And this is actually going to be a really quick video, so let's just jump into it. The first is this sort of situation. You should have seen this before in even like Algebra 1. But we have two similar triangles. The classic one here is shadows, right? So we have the sun is far away and it comes from the same angle, at least for things that are close by. So therefore, the shadows will be proportional. So if there's this 1 meter tall stick in the ground that makes a shadow that is 1.6 meters tall, and then a tree of unknown height that makes a shadow of 7.2 meters long, what is the height of the tree? And the fact is that these two triangles here are similar, so therefore the sides are proportional. Again, we can set it up. The book has us doing, let's see, AB over xy, so they're doing the corresponding, making a fraction with the corresponding sides. You could also do it with adjacent sides as well. So for example, to me, it makes a little more sense to do like, what? I messed this one up. I think it makes more sense to do it kind of adjacent sides, like 1 over 1/6, 1.6, 1 over 1.6. So in this case, it's xy over zy, which I think the book did here, but I think that's an error. And then that's equal to, again, AB over CB. What I think happened is that they started it the way they usually do it, and then they finished it the more intuitive way, which is this way. But it doesn't matter. However you want to put it, it's fine. 7.2. And then you solve from there. Since our variable is on top, we can just multiply both sides by 7.2 and it spits out our value. If the variable is on bottom, then you have to cross multiply or get the reciprocal of both sides, something like that. Okay, the other situation is pretty similar actually. We still have two similar triangles. And instead of being one looking like the other in the same orientation, they actually share this vertical angle here. Therefore, we know that they're similar. And the way this works is he picks a point that is opposite this canyon. And so that's y. And then he walks a known distance, right? Puts a point, walks another known distance, and then goes perpendicular to it until he lines up. So everything on this side of the canyon is doable, right? You can do W, V, Z, and Y. The only thing we don't know is X, and that's this thing on the other side of the canyon. And that could be a tree or whatever. Doesn't scenario. So the point is we have two similar triangles here. And just like before, we can say that the sides are proportional. So this time we do 400 over 600. So 400 over 600. You could also do 400 over D. I'll do that one. 400 over D. Lowercase d. And that is equal to, and the question is which side corresponds with this 400-foot leg? It's the 600-foot leg here, right? Because they share an angle. Okay, so that's the 600 over 327, 27. And remember, I usually prefer to put the variable on top, but we can just crank through this. If you cross multiply, you get 400 times 327, and then that's equal to 600d. So you divide by 600, so it becomes 327 times 400 divided by 600. Some people call it like the fish method, right? Like this times this divided by this is equal to that. Sure, that works too. Okay, see if you can do this one real quick. So pause there. Yeah. And hopefully you come out to 20 meters. But you can also kind of mental math this. What is 42 to 35? Well, if you make that a fraction, and divide both the top and bottom by 7, you should be able to figure out that 42 over 35 is the same thing as 4 over 5. Wait, 6 over 5. 6 over 5. That's going to be equal to 24 over something. So what's 5/6 of 24? 24 divided by 6 is 4, and then times 5 is 20. So that's equal to 20 over 24. There. That's all I got. Those are just the two situations, and we just treat them like our similar triangles. Nothing too hard. Okay, have a good one.